Hi, this is Catherine Rabick from CSC578, the online section. This is my video walkthrough of homework 1. So first we're going to look at evaluate. So what I did here was I actually made up my own list of the results using just self-feed forward rather than the argmax. So I've been utilizing this list to get my results for the equations. So kind of how this works is I just created 3 empty lists, and then every time I get the mean squared of an xy tuple, it just appends to the mean squared list. And then what we can do is we can actually reassign this to the sum and divide it by n this way. So it's all kind of done all in the same function here. And then what it does is it just returns all the results that we get from those equations back. I will mention that correct vowels is just what I named the original correctness that was already in here. So that can actually be sent back to the color of the function as well. And the color of the function is SGD, which is up here. So what I did for this one is you will notice that evaluate's only called once for each data set. So once for training data, once for test data. And also of note here is that evaluate's only called on test data if the test data exists. So when we're creating our history, essentially how mine works is if you don't have test data, it just gives you back a blank list. So here we have just all the formatting for the print statements. And you can see here that for train accuracy, I just did, the correct value divided by how many values there were total. I did have here, I returned the history whether there's early stopping or not. So you're still going to get the history back, whether it stops on the 15th epoch or whether it goes all the way through. For the early stopping, pretty much I just set it up so whenever training accuracy is at 100%, it prints this and then just breaks. So now we can look at the back propagation. The way I did this was I just set up like a blank list, and I appended X to it because X, the inputs just kind of stay the same throughout. But then for, all hidden layers or output layers, all that kind of stuff, what I did was, for any I in the range, between 1 and the total length, it's going to append to my empty activations list just a vector of zeros. And that zeros, like if you have a hidden layer that's of size 8, it'll just do like a column of 8 zeros. So when we're running through, I just created a counter starting at 1 for, the first hidden layer. That's kind of where it starts. And then every time it does the sigmoid of, any of the, pertinent nodes that we're looking at, it's going to set that activation to the location in our activations list that we have. Sorry, I'm losing my voice a little bit. So this is just like an index-based assignment. And then you just print the activations, and this is the line that we can comment out as well. So we only use it for, the first experiment with the first IRIS data set. So I did want to show that this runs, but some of my networks for the IRIS CSV are very long, and they take a little while, so I didn't want to, bog down the whole video. So I did comment everything out aside from the first experiment to confirm the MSE cross entropy and log likelihood, and everything does run correctly. So I did want to show that here at the end of my video. Let me just make sure I actually saved this. Okay. Let's see if we can run this really quick. Oh. Okay, so you see that you do get your activations list, and that is correct. I'm sorry, the formatting is not not great, but all those values are correct, as well as the training and test. Those all match expected as well. And this just, I have it printing every time it hits 100, so that's why that's there. All right, that's it. Thank you so much.